So good morning students. Today I am giving the introduction about the business statistics. So first you have to learn what are the learning objectives of the business statistics. So while coming to the first objective, how businesses uses statistics, the basic vocabulary of the statistics, how to use Microsoft Excel with this work. Why learn statistics? Means make better sense of the world. Internet articles, reports, magazine articles, newspapers articles, television and radio reports. While coming to the business decisions, business memos, business research, technical journals, and technical reports. In businesses, statistics has many important usages. To summarize the business's data, to draw the conclusions from business's data, to make reliable forecasts about the business's activity, to improve business's processes. Two different branches of the statistics are used in businesses. While coming to the statistics, the branch of the mathematics that transforms the data into useful information for the decision makers. So, and two different branches will be descriptive statistics and inferential statistics. While coming to the descriptive statistics means collecting the information, summarizing, presenting, and analyzing the data. While coming to the inferential statistics, using data collected from a small group to draw conclusions about the large group. That means in the inferential statistics, you have to gather the information from small group to large group. These two branches are used in the important activities. That means in the statistics, uses of the statistics means we know about to summarize the business's data, to draw the conclusions from the business data, to make the reliable forecast about the business's activities, to improve business's process. These are the uses you already know. Then these two tools will be used. These uses. That means to summarize businesses data means here you have to use the descriptive method for creating charts and tables. While coming to draw the conclusions from the business data, here you have to use the inferential method to reach the conclusions about a large group based on the data from a small group. While coming to make the reliable forecast about the business's activities, here you have to use the inferential method to develop, quantify, and improve the accuracy of the predictive models. While coming to the improve businesses process, involves managerial approaches like Six Sigma. While coming to the descriptive statistics, so step number one is collecting the data, and the step number two is presenting the data, and the step number is characterizing data. While coming to the collecting the data information, one of the best example is surveys. So some surveys you have to gather some information. Then that information will be shown through tables and graphs, that is the presenting data, and after the completing of tables and graphs you have to identify the sample mean, so that will be used in the characterizing the data. So that's why you have to take the collector the data, present the data, characterize the data will be descriptive statistics. While coming to the inferential statistics, estimation and hypothesis testing will be used. Estimation means you have to estimate for the forecast. That means one of the best example is estimate the population mean weight using the sample mean weight. Under that you have to identify the sample mean weight using identify the population mean weight. While coming to the hypothesis testing, hypothesis means one of the estimation to test the difference between population and sample will be called as the hypothesis testing. For example, test the claim that population mean weight is 120 pounds. Basic vocabulary of the statistics. That means which terminologies you have to use in the statistics means variables, data, and operational definitions. So while coming to the variables, variables are the characteristics of an item or individual and are what you analyze when you use a statistical method. Then come to the data. Data are the different values associated with a variable. Then come to the operational definitions. Data values are meaningless when unless their variables have the operational definitions. Universally accepted meanings that are clear to associate with an analysis. That is the operational definitions. Then population. Population means set of individuals belonging to a particular variable. Here the definition means a population consists of all the items or individuals about which you want to draw a conclusion. The population is the large group. While coming to the sample, sample is the one of the subgroup. That means a sample is the proportion of a population selected for analysis. The sample is a small group and a sample is collected from the population only. Then the parameter. A parameter is a numerical measure that describes a characteristic of a population that will be called as a population. That means you have to identify the characteristics involved in the population will be called as the parameter. And then coming to the statistics, a statistic is a numerical measure that describes the characteristics of a sample. Which types of characteristics will be used in the sample that will be called as the statistics. Which characteristics will be used in the population that will be called as the parameter. So then population versus sample. We already know the definition for population. Population means a set of variables belonging to a particular variable. So that will be called as the population. In this diagram, we are seeing the population. So here infinity, that means population will be there. In that population, I am selecting some samples. Here the sample diagram. Here the sample diagram, we are seeing the red color marks. That will be the samples you are selecting. So these samples are selected from where? So in this population only. That's why measures used to describe the population are called the parameters. So for that samples, measures are described the sample are called as the statistics. That means population and samples. So in this chapter, okay, we will tell the summary. So introduce the basic vocabulary of the statistics and the role of the statistics in turning the data into information to the facilitate decision making. Then examined the use of the statistics to summarize the data, draw conclusions from the data, make reliable forecasts, improve business process, examining descriptive versus inferential. Then step-by-step process for examining and concluding from the data is helpful. Here you have to use DCOVA. DCOVA means you have to define, then collect, then organize, then visualize, then analyze. So these 5 tools will be called as the DCOVA. Define, collect, organize, visualize, and analyze. While coming to the define, step number 1. Define the variables for which you want to research conclusions. So first you have to define which type of variables will be used for our research work. So that will be called as the define. Then collect. So collect the data from the appropriate sources. Then you have to gather the information depends upon our sources. Then step number 3, organize the data collected by the developing tables. So in step number 2, we have collected some data. Then step number 3, we have to organize the data collected by the developing tables. Then come to the step number 4, you visualize the data by developing charts. In step number 4, we have to show the graphs from the information gathered in the step number 3 and organizing. While coming to the analyze, step number 1, Analyze the data by examining the appropriate tables and charts. That means you have to show the tables and charts that will be called as the analysis. These are the 5 steps we have to use in the for examining and concluding from the data is helpful. Then types of variables. So types of variables means two types. Categorical variable and numerical variable. Another name for categorical variable is qualitative variable and another name for numerical variable is quantitative variable. So qualitative variables have values that can only be placed into categories. That means such as yes or no. In the questions, we given the yes or no questions. If they are answered either if it is will be correct, they put yes. If it will be wrong, they put no. So that you have to identify the category. That will be called the categorical variables. While coming to the numerical variables, that means quantitative variables have the values that represent the quantities. So depends upon the discrete variables and continuous variables. So discrete variable means counting process and the continuous variable means measuring process. For example, number of samples in a group means 1, 2, 3, 4, 5. That will be called as the numbering. That's why it will be called as the discrete variables. But depends upon the ages that means or weights, not ages or weights. It means that means 44.5 and its weighs and 60.5 or 60. So these will be process will be the continuous variables. Then types of variables. So two types of variables we already know, categorical variables and numerical variables. While example for the categorical variables will be material status, political party and eye color. So these are the uses in the category. While coming to the numerical, discrete, first one, number of children and defects per hour. Then come to the example for continuous is weight and voltages. That will be. Then next topic is sources of data. While entering into the sources of data, first you have to know what is meant by data. Data means gathering the information. So and it will be defined as two types. Primary information and secondary information. Primary information means you have to gather the first time. That information will be called as the primary information. Depends upon the data. You have to collect some other data. Depends primary data that will be called as the secondary data. While coming to the primary sources, the data collector is the one using the data for analysis. That means data from a political survey, data collected from an experiment, and observed data. While coming to the secondary sources, the person performing data analysis is not the data collector. The person performing the data analysis is not collector the data collector. That means analyzing census data, examining the data from print journals and data published on the internet. That means primary information will be gathered from the political survey. Depends upon the service. The person will be collected the data. But while coming to the secondary data, the person performing the data analysis is not the data collector. Here you are not the data collector. Here you have to gather the information depends upon the census data and that means already completed data. That means almost all completed data you have to gather. That will be called the secondary data. Then sources of the data fall into 4 categories. Data distributed by organization or an individual, a designed experiment, a survey, an observational study. Organizing the numerical data, frequency distribution. Organizing the numerical data, frequency distribution. One of the example may is here they given the database 12, 13, 17 up to the numbers will be starting number 12 to 58 number will be there. That means here you have to write the data information step number 1. First write the data in ascending order. Ascending order means write the data from smallest number to highest number. Then step number 2, find the range. Range means highest value minus least value. Here the range value is 58 and the highest value is 58 and the least value is 12. So highest value is 58. 58 minus 12, 46. That is the range value. Then step number 3, select the number of classes So totally 5 classes will be selected. Why? Because of here 12, 13, 17 is lies between 10 to 20 and 21, 24, 25, 24, 26, 27, 27. And these values will be in between of 20 to 30 and 20 and 30, 32, 35, 37, 38 will be between 30 to 40. 41, 42, 43, 44, 46 will be between 40 to 50, and 53, 58 will be between 50 to 60. That's why I'm categorizing 5 categories. So that's why I'm selecting number of classes will be 5 classes. Then compute class intervals with 10. So differences is 10 differences. Then determine the class boundaries. So class number 1, 10 to less than 20. Class number 2, 22 less than 30. Class number 3, 32 less than 40. Class number 4, 42 less than 50. Class number 5, 52 less than 60. The next step is compute the class midpoint. Here you have to calculate the mid values. How we will calculate the mid values means here 10 is the lower limit and 20 is the upper limit. So first mid value is 10 plus 20, 30, 30 by 2, 15. So first mid value is 15. Then 20 is the lower limit and 30 is the upper limit. 20 plus 30. So 50, 50 by 2, 25. 25 is the second mid value. Then come to 30 plus 40. 70, 70 by 2, 35, 35 is the third mid value. Then 40 plus 50, 60, sorry, 90, 90 by 2, 45, 45 is the fourth mid value. 50 plus 60, 110, 110 divided by 2, 55, 55 is the last mid value. Then count observations and assign the classes in the next slide. Here we are organizing the numerical data, frequency distribution. One of the example is data in ordered array. So in a last slide, you already seen the some data from starting 12 to 58. Here I am dividing the class intervals and midpoints and frequency. So class intervals is 10 but less than 20. So 10 to 20 and that means 10 to 20. So 10 to 20, the values will be in between of 10 to 20. The values will be 1, 2, 3. Here the class interval is 3. Then come to the 20 to 30. In between of 20 to 30, 1, 2, 3, 4, 5, 6. The frequency is 6. Then come to the 30, between 30 to 40. 1, 2, 3, 4, 5. The frequency is 5. Then 40 to 50 in between. So 41, 1, 2, 3, 4. The class in that means the frequency will be 4. Then 50 to 60. So 53 and 58, 2 will be there. Then the frequency for 50 to 62. Here the and the midpoints will be 15, 25, 35, 45, 50. The total frequency will be 20. So these are all the samples will be the 20 samples we are taken. So in between of 10 to 23 frequency, in between of 20 to 30, 6 frequency, in between of 30 to 40, 5 frequency, in between of 40 to 50, 4 frequency, in between of 50 to 60, frequency will be 2. The total frequency will be 20. Then come to organizing the numerical data. Relative and percentage frequency distribution. That means in the class interval, frequency. So relative frequency means how can you calculate the relative frequency means 3, 6, 5, 4, 2. Total frequency will be 20. Now the relative frequency for the first class interval is 10 divided by 3 divided by 20. That will be 0.15. Then the second class interval relative frequency will be 6 divided by 20. That is 0.30. Then 5 divided by 20. The relative frequency is 0.25. 4 divided by 20. So the frequency will be 0.20. And 2 divided by 20. The relative frequency is 0.10. Then convert into percentages. So 0.15 into 100, that will be 15%. 0.30 into 100, that is 30%. 0.25 into 100, that is 25%. 0.20 into 100, that is 20%. 0.10 into 10, that is 100%. Sorry, 10%. So total percentage will be 100 and the total probability will be 1. Then organizing the numerical data, cumulative frequencies. Cumulative means you have to add one by one. That means here the class interval will be there. So 10 to 20 and the frequency will be 3 and the percentage will be 15 and the cumulative frequency is 3 and its cumulative frequency percentage is 15. Then come to second class interval 20 in between of 20 to 30. The frequency is 6 and its percentage is 30. Then its cumulative frequency is 3 plus 6, that will be 9 and its cumulative percentage frequency is 45 percentage. How? That means 15 plus 30 is equal to 14. Then the cumulative frequency for the third class interval is 14. That means 3 plus 6 plus 5 and 9 plus 5, 14. And its cumulative frequency percentage is 70. Then the cumulative frequency for the fourth class interval is 18. That means 3 plus 6 plus 5 plus 4, 18. And its percentage is 90. Then the last class interval frequency is 2. Its cumulative frequency is 20. So 18 plus 20. So that is equal to 20. Sorry, 18 plus 2, that is equal to 20. Its total percentage is 100. Then why use the frequency distribution? Means it condenses the raw data into the more useful form. It allows for a quick visual interpretation of the data. It enables the determination of the major characteristics of the data set, including where the data are concentrated and clustered. Then visualizing categorical data. First visualizing is we have to use the visualize and you have to show that how the data will be shown. Here you have to use some charts. By showing the charts you have to see that in a bar chart. First I am taking the bar chart. In a bar chart, a bar shows that category, the length of which represents the amount, comma, frequency or percentage also of the values falling into a category which come from the summary table of the variable. Here I am taking the example table. So banking preferences and its percentage. So first one I am taking the first option ATM. Second option will be automated or live telephone. And the third option will be drive through the service at the branch. And the fourth option will be in person at branch. And the fifth option will be internet. So I am giving the bank preferences will be 5 options. For the first option ATM, that means 16% of the persons will be accepted. While coming to the automated or the live telephone, 2% will be drive through service at the branch is 17%. In personal at branch is 41% and internet banking is 24%. Total 100%. So that means now you have to show this table format through the graph. So banking preferences. So first one is ATM. ATM how much percentage? 16%. So up to 16% will be there. Then automated or the live is 2%. So here you have to draw the graph up to 2%. We are drawing the graphs through horizontal lines. Then come to the third one, drive through service at branch is 17%. So here draw that line up to 17. Then come to the fourth one, in person at branch is 41%. So 41% up to down. So for internet banking 24%. So which option is the best option? Means in person at a branch is the best option. We can answer that question by seeing the graph. So that's why you show the data information through the graphs. It is easy to understand and identify the people which is the best option. That's why you are using the charts. So one of the bar chart is completed. Then come to next pie chart. Here you have to use the using pie chart. In last slide you are using the bar chart. Here I am using the pie chart. So pi means total 360-degree circle. In this you have to show the degrees. So first one 41, that means ATM is 16%. This is the ATM. Then 2% is automated. Then 17% derived through the services. Then 41% is the in-person at branch and 24% is internet banking. So here you are showing this data information through the pie chart. Then visualizing numerical data, the histogram. Here the histogram, the vertical bar chart. So here you have to know what is meant by vertical and what is meant by horizontal. So here you are using the vertical. In the last slide, we drawn the slide, we drawn the charts, the horizontal lines. Here we are using the vertical lines. Here a vertical bar chart of the data in a frequency distribution is called as the histogram. In a histogram, there are no graph between edges and bars. The class boundaries are shown on the horizontal axis only. The vertical axis is either frequency or relative frequency or percentage. The height of the bars represent the frequency, relative frequency or the percent. Depends upon the highest frequency that shown the height of the bar. One of the example is, so this is the table. This table will be shown the histogram. So first one is 15 percentage. Percentage is only you have to draw 15. So 15 percentage, then 15, then 30. So this is the term. No. It depends upon the frequency. So I'm taking the 10 units. So first 10 units, that means 10 to 20, 10 units will be, frequency will be 3. Here you are drawn the 3. Then in between of 20 to 30. So this is the bar. So this bar will be 6. And this bar will be the 5, and this bar will be the 4, and this bar will be the 2. So this is the histogram. Then visualizing the numerical data through the polygon. First, the percentage polygon is formed by having the midpoint of the each classes represent the data in that classes, and then connecting the sequence of the midpoints that their respective classes percentages. The cumulative percentage polygon or Ogive, displays the variable of interesting along the x-axis and the cumulative percentages along y-axis. Here you are using the graphs x-axis and y-axis. The cumulative percentage polygon displays the variable interesting along with x-axis and cumulative percent along y-axis, x-axis and y-axis. Useful when there are two or more groups to be compared. Here I am showing the frequency polygon. So class interval table midpoints that 15, 25, 35, 45, 50 and the frequencies will be 3, 6, 5, 4, 3. So I am taking the first. So first class interval midpoint is 15. First starting 5. First, then 3. Then next in between 25 midpoint is 6. In between 30 to 50 midpoint is 35. 35 frequency is 5. And 40 to 50 midpoint is 45 and its frequency will be 4. In between 50 to 60 the mid value is 55 and its frequency is 2. Then 60 to 70 is 65. Its mid value is on x-axis. And then the starting point is started from the axis only on the line and it will be ended on the line. Then the remaining frequencies will be shown in between x-axis and y-axis. So this is the class interval midpoints. X-axis is denoted by class interval midpoints and y-axis is denoted by frequency. This is the polygon tag chart. Then visualizing numerical data from Ogive. Ogive, in this you have to use a cumulative. So first, starting is 10, lower class, next 20, 30, lower classes you have to use. So for the 10 starting lower class, 15 percentage, then you have to cumulative, then 15 plus 45 percentage. So starting 10, 15, then 45, then 70, then 90, then 100. So this is the process of Ogive cumulative. That means Ogive means cumulative of the polygon. Visualizing two numerical variables through the scatter plot. Scatter plots are used for the numerical data consisting of paired observations taken from two numerical variables. One variable is measured on the vertical axis and the other variable is measured on the horizontal axis. In these two types of axes will be there, x-axis and y-axis. X-axis is on horizontal line and y-axis on vertical line. Scatter plots are used to examine possible relationships between two numerical values. So these scatter plots will be used in the calculating the relation between two variables. Scatter plots, volume and volume per day and cost per day. So volume per day is 23. That means x-axis I am taking volume and y-axis I am taking the cost. For the x-axis I am taking 23. So here starts from 20. Here I am taking 23. 23, 125. That is the first plot. Then 26, 26, 140. Then 29, 146. Then 33, 160. Then 38, 167. Then 42. Here the 42 will be there. So 140, 170. Then 50. Exactly. So 50 is 188. Then 55, 195. Then 60, 200. So this is used for scatter plots. That means you have to use the relationship between two variables, volume per day and cost per day. Here I am concluding that topic of business statistics introduction. Then we will continue the topic, the next topic, measures of central tendency, next class. Okay, thank you. Thank you, friends.